Okay, so the code that I wrote did a bunch of things. It would scrape the website, so that's nice because I can use old Python nice scraping libraries. And then it would do data analytics on this with scikit-learn and plotting with word cloud. Okay, so as I said, crawl, scrape, that's nice. And then we get a set of strings. And I need numbers. So what am I going to do? I'm going to do what's known as vectorizing, which means that I'm going to transform these strings in vectors, in arrays. And the way I can do it is I count the number of times each word appears in a string. Okay? And so then each string is represented as what we call a bag of word, which is that it's the frequency of all the words in the string. Okay? Now, we're looking at a Python conference, so not every word will have the same importance, right? So if I'm trying to tell what this talk talks about, well, the word is not very important, but the word performance is probably very important, even though is much more frequent than performance, okay? And Python may not be that important because it may be common to all the talks. So what we're gonna do is that we're gonna count in all the documents how often each word occurs, and then we're going to do the ratio between the two, okay? The ratio between the frequency in my specific document and the frequency in all the documents. So this is known as the TF-IDF transform, okay? And so here we get a vector of numbers, of floating point numbers, of real numbers, that capture more or less the information, the semantic information of my talk, okay? And then we do this across many documents, so across many talks. And then I have a matrix that is term by document. So it's how each term is expressed in every document. Now, in practice, it's rather a sparse matrix because many terms are almost never expressed in documents, but that's a detail. So then what we're going to do is that we're going to factorize it. And by factorize it, I mean that we're going to find a small number of combinations of terms that explain well the variation of terms across the documents, okay? So we have a small number of combinations of terms that we call topics. A topic here is a combination of several terms that are loaded differently. And then we have a loading of the topic across the documents, okay? And how to do this? This is basically a matrix factorization, so I'm happy. I can go back to math, I can minimize functions and do things like this. And then the challenge of machine learning is to find good constraints on this matrix factorization to reject the noise and find interesting things. And one good constraint that is often used is to say we don't want any negative values in there. So I don't want topics that are loaded negatively. I don't want to say this is not a talk about performance. I want to say this is a talk about performance, or this is a talk about something else, okay? And so non-negative matrix factorization on a TF-IDF transformation of the data works really well. You can try it at home with scikit-learn, for instance. It will capture some information, hopefully. So what we get are things like this. So the topic number 1 is about Python programming. Then we have a topic number 2, which is basically about data science and machine learning. And a topic number 3, which was about something like testing, I can tell. And we get many topics. So what I'm trying to tell you here is that by using these numerical modeling, so by using this numerical modeling, even on things that is not naturally numerical, I can capture some information, okay? And this is becoming really important these days because I think the breakthrough in artificial intelligence that we're seeing here currently is partly related to this. If you go back in time and if you look 20, 30 years ago, people were trying to do what's known as symbolic artificial intelligence, and it's not dead, it's still alive. There's still really interesting things. But the recent things that we're seeing are really about writing everything as vectors because it's easier to do mathematical modeling of vectors, okay?